So a lot of what we do with fish is looping, one way or the other. We've got a model, it's got lots of zones, and we're almost always wanting to basically access information or assign information in those zones or structural elements or grid points. And quite often we want to limit them in some way as well. And that's where groups and ranges come into play, which I think you guys talked about on Monday. So there's a couple different ways to loop that are built in. This first one is essentially a way, it's mostly used as a counter. So I'm looping, so I've got fish define, I've got sum of n. So n is that argument that we just talked about. So when I call this fish function called sum, I'm actually inputting into the function the value of 10 for n. I've got a local variable that I'm calling s. I'm resetting it to 0. Quite often when you're doing a counter, if you're going to keep using that counter over and over, you might want to start at 0 so it doesn't continue on from some previous run. And then there's this kind of nomenclature here that I'm a mining engineer. This is more of like a C++ type. I don't know, maybe Python does it. But basically, I just have a little note here. If you ever see in the examples s plus equals something, it's just s equals s plus that. So it's just a shorthand of this equation. And I guess when you're writing millions of lines of code, every character counts. So that's something that's built into fish now. So we've got this loop, end loop, and we have another loop called loop while, and then a loop for. This is probably the most useful and that one that you'll use the most. I would call this the modern loop. Wait, I'm sorry. There's actually one other one after this. That's the one that we're going to focus on. But this is just kind of a combination of these two. So what is it doing? We've got a loop, sum 10, and then s is going to equal s plus I. So each time this loops, it goes through this calculation sequence. This variable is going to increment by 1 by definition. And it's going to do that 10 times. So essentially, this will be the sequence of s. It'll be 1, and then it's going to be 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, etc., until we get to 10. And if we add up all these numbers, it's going to sum up to 55. And essentially, it's just a straightforward increment of 1 value as we're each time we loop. Here, we can have a condition. So I want to loop, but I don't want to loop to 10 or 100 or some other thing. I want to loop until some condition. So it could be some value is this, the cycle number of cycles is 12 million. Now I want to stop doing something. Or in this case, it's just n, which is 11. So it's essentially similar to what we did before, but we're just going to go one more increment. And essentially, we're saying do that until that value is less than or equal to 11. We could have it do it while it's not 12, and then it'll keep doing it. Once it hits 12, it'll stop. There's all sorts of options. And then this is kind of a combination. This loop for lets us essentially start at some value. It doesn't have to be 1, it doesn't have to be 0, it could be 1,000. Put a condition in, do that until it's less than or equal to 12. And then the neat thing here is we can define the direction. So these other ones all, or the first one basically says, I'm going to keep adding 1. But here, it is adding 1, but I could make that 2. I could make that -1. So I could start at 100 and count down. So it's just sort of a couple helpful little tools for looping through numbers, or they can be looped. There are ways to loop through objects in the model as well. The one you're going to use the most, though, is the most modern version, and it's called a loop for each. And essentially, we have what are called containers. Containers are just lists. We talked about lists before, but in this case, it's a built-in list of all the zones, all the grid points, all the structural elements, all the faces, everything. And so it's really helpful or really quick and efficient when we want to loop through, in this case, say all the zones. So it all goes down to these intrinsics. We have a zone.list, we have a grid point.list, we have a struct.list. So pretty much every object, if we were in 3-deck, we'd have a block. Pretty much any of these sort of objects that we have that make up the model have lists already predefined. So when you create a 20 by 20 model, they get added to this list. And so what we're saying here is we want to loop through every one of those things in the list. And what that lets us do again is we could then put conditions on it. If, as we're looping through all these zones, this zone belongs to this group, or it's above a certain elevation, we could change properties. We could ask it for some information. We could set a boundary condition or apply a force. So that's where you start to get into something that can be really useful. So instead of a command group, it just gives us a little more flexibility. Very efficient and fewer lines of code. So here, let's look at exercise 5. Just a couple lines of code. I'm going to turn off the command so we got a little more stretching room. Okay, so model new resets everything. We're just building a different way of building a model. We're doing a zone create 2D quad. Before we had, I think, size 2020. In this case, it's size 6.6. So it would be 6 zones by 6 zones is size. But if we don't define actual points, I believe all the zones will be 1 unit. So this just lets us actually define what the scale is by defining 3 points. And I think, yeah, here in the slide, there's actually a link back to the online documentation. And that just took me to here. Brick, I think that's the 3D ones. Create 2D. Quadrilateral, we did quad, short for quadrilateral. Most of these things can be truncated. And so when I actually look at the diagram, these is 0.0 is here, 0.1, 0.2, 0.3. These are just reference points. So, and this is just an intrinsic basic mesh that's part of the software. So that's just to say what all these numbers are referring to. 0.0 has this coordinate, 0.1 has these coordinates. So although it's 6 by 6, the physical dimension is going to be like 2 on the side. Then again, I'm just going to assign a constitutive model to be elastic to all the zones. One thing that's a little different, I'm going to use this command model random. In this case, 110. It's just, so I picked that number out of my head. So it's, I guess, arguably truly random. In the software, it's pseudo-random. So there's some equation that it's using to generate random numbers. And depending on the seed value, you can always, if you assign a seed value, it'll always give you the same random number because it's tied to the same seed. I'm not quite sure what it does normally, if it's like using the clock or something like that to seed it. But this way, when we run it, we'll all get the same output. And if you're testing something, it's kind of nice to have the same random number come up. And then when you're done, if you wanted to do 10 models, but with random properties, then you could turn off the seed. And then we've got this simple little fish function, fish define set extra. So hopefully you know that all the zones, pretty much all the objects, structural elements, grid points, everything pretty much can have extra variables assigned. which are really handy when you want to do something custom. So say there's a plot item that we haven't thought of that's important to you. Say you've got some ratio of principal to minimum stresses, and based on the depth and based on the moduli of a zone, and you want to plot that. Well, we don't have that as a built-in plot, but if you assign that calculation, that calculated value, to an extra variable, you can plot an extra variable. And you can have, I think, 100 or 200 extra variables to any one thing. So if you've got 20 custom plots that you want of some value that we don't have, extra variables become really handy. You can also use them to tag something. You could say, if this zone lives here, I want to tag it with a value of red or 1. So what we have here is our normal little fish function. And then just one thing really quickly, these little boxes here, that just lets us collapse the fish function. So if you've got lots of fish functions and they're kind of in the way, and you just want to minimize it, you can just close those and then expand them. Same for loops, because sometimes you might have loops within loops within loops, or conditional statements within conditional statements. So anything that kind of has an end in it kind of has this little bracketing function. Also note that when I do this out of habit, I kind of indent. And so I find that it's really helpful, because if it's, say it's a bigger function with maybe 20 or 30 lines, it really makes things stand out. So I know that everything that's offset this far, indented this far, belongs to this loop. It's inside that loop. And I know everything that's indented once is inside that fish function. It's just kind of a habit. Even here, when I use the 3 dots to make a second line, or to split the line into 2, I indent it so it just reads a little easier. So we have loop for each. Some variable that I picked, I think it stands for address, but it's just, could be Fred, could be George, could be Harry. And then zone list is important, because that's what I'm going to loop through all the zones. Could be all the grid points, could be all the faces, could be all the structural elements. So zone extra is an intrinsic, so it is just a way to, in this case, assign a value to the zone extra for each zone. So as it's looping through each zone, it's going to assign an extra variable to that zone address. And that's really what this is. It's a pointer that essentially identifies this zone from another. And then this 1 is, what's the right word? Slots. So we have extras, but each extra can have multiple values. So those are referred to as slots. I kind of think of them as like an AutoCAD drawing with layers. And so 1 is just the index. So this could be 100 if you wanted. And then here, this is a intrinsic built-in fish function. And it's just, as you sort of use it and as you look through the documentation to see what's available under math or under utilities, as you work with examples, you'll just start to get used to these things that are available. So math.random.uniform will give us a uniform distribution. It can have some arguments. We won't go into that, but basically I don't have any arguments to give it to modify that. So I just have these 2 empty brackets. And then of course, if we loop, we've got to end the loop. So when we do this and we run it, if we didn't have anything inside the loop, it would just look through all the zones. It wouldn't do anything. It wouldn't change anything. It wouldn't report anything. But because we're essentially issuing an action using fish, again, we could have a command in there, but you can add extra variables through commands, but that would be much slower than using the fish version. So if we run that whole thing, here are the old stuff. So I don't have it spitting anything out to the console, although I do have that turned off. So nothing. So what I'm going to do now is go split right. And I'm going to make a new plot. And move that over. So then I'm going to go here and I just want a zone. So I use the quick list. There's a plus here that'll bring up all the things that we can do. Same difference, zone. And actually, I'm just going to close that so we can see what we're looking at. So what we want to plot are extra variables. So if I go to zone, is the plot item, label should work. I'm looking for extra. And now I've got these extra values. And since we use the same seed value, we should all have the same values. I find sometimes the color plot doesn't come out identical, but these values should all be pretty much what you guys have. If we had used different seed values or didn't specify a seed value, then it would be pseudo-random. Okay,